All right, welcome to part 6 of the power simulations tutorial. Okay, so in the last video, I showed you guys how to make the electrical parts of our rover model. So as you can see here, I have the 6-wheel model set up. This is the updated model that I put on the GitHub. So if you were following along with the model used in the last video, I suggest you go and grab this from the part 5 GitHub link. This is what I'll be using for this tutorial video. So basically, it's the exact same model as we used before, except we now have 6 wheels set up with 6 voltage sources and 6 DC motors. This little section here, I added this so that I didn't have to put voltage and current sensors over every motor because that would get kind of messy and hard to look at. But because we're giving the same signal to every motor and they all have the same properties, they're going to have the same current and voltage consumption. So I just multiplied the current and power consumptions by 6. Hopefully that makes sense to you. And yeah, so I'm just going to show you real quick. So last time we said that the current and power consumption of one motor going from a 0% duty cycle stepping up to a 100% duty cycle used a lot of current. I'm just going to show you really quick what I mean by how much current it actually uses um, when it's used on all 6 motors. So if you take a look here, this yellow line is the power. So we're hitting roughly around 3,600 watts, which is ridiculous at a peak. And then the current here, it's also maxing out around, it's dropped down. It's also getting up to like 260 amps. I don't even think that was the peak. But anyways, that is like way, way, way higher than we need. Like than we are allowed to use on a rover. So that is something we have to be careful about. So in order to make sure that doesn't happen, what we need to do is make sure that we never go from 0 to 100% duty cycle. But right now we've just been working with a step input where we have some initial duty cycle followed by a step up to some final duty cycle after a specific amount of time. But that is not really sufficient for actually modeling a whole trip of the rover. So say the rover is going out and is completing a certain task in the competition. This is not going to be sufficient for determining how much power it's going to use. Ideally, we want to be able to track out the power consumption over a specific amount of time where we change the duty cycle. So maybe we want to have it start off slow. So we want it to go up to 20% duty cycle for a little bit. And then as it starts getting faster, then we can increase it a little bit and start to max out around 70% duty cycle for a little bit. In order to do that, we actually have to create custom signals because there are, like, unless you created some sort of MATLAB function to give that sort of input, uh, you can't really make that using MATLAB blocks. So what I'm going to do is I'm going to show you something called the signal editor. So I'm just going to type into here, signal editor. And this brings up the signal editor block. So I can get rid of this duty cycle here, and I'm going to put in the signal editor block. So basically what this does is it allows us to create custom signals however we want. So I'm going to open this up, and I'm actually going to, I first have to browse to a map file. So I need to actually open this up first. So this is the signal editor tab. So if I open this up, it'll create a untitled signal editor file for me, or untitled map file for me. So what I'm going to do is I'm going to save this, save as, let's go with signal var, yeah, let's just go with signals. We'll call it signals. Save that. So now we have a signals file. So I'm just going to close this, and okay. So it created the path to signals file for me, which is good. So I'm just going to bring up the signal editor again. And basically what you can do with the signal editor is you can create scenarios that hold specific signals. So if you can see here, like this scenario, it holds something called signal 1. I'm actually going to rename this. Let's say I want to name this scenario fast start. And we're going to call this signal duty cycle because that is what we are wanting our input to be. So I'm just going to hit this check mark here, and we can actually go to a plot of our signal. So this is how we can actually draw our signal data. So you could, if you wanted to, import data from like a separate mat file, or you could create a MATLAB function or expression to send out all these values for you, or you can directly edit all these points inside the table. That's fine. But something that is really neat is the fact that you can actually draw out this signal. So I'm going to show you how you can do that. Oh, I just clicked and added a point there. Okay, I didn't know I could do that. Okay, I'm just going to, yeah, so we're on edit here. We got point. So I'm going to hit this hand button. So that will allow me to move the graph. Now let's see if I can set a point somewhere. So let's say we're doing fast start. So after 1 second, I want to be hitting around, let's say 0.4. No, let's just start off right away. Let's hit around like 25% duty cycle. So I'm gonna put a point here. So that's pretty close to 25. I'm gonna set it right to 25, and I'm gonna set this time also to 0.2. So you can get a point pretty close to where you want it, and then just edit it here in the table. Now say I want to add another point. Okay, we're gonna wait until about here to get to 50% duty cycle. Let's change that to 0.5. We'll change this to 1, just so it's a little exact. And then we want to get right up to maybe, yeah, let's do 80% duty cycle. 0.8 at 2 seconds. And then we want to hit, let's say, 100% duty cycle, which I would not suggest doing this for too long, but I'll just show you what happens. So we'll set up 100% duty cycle here. And let's say we want to do that for starting at 3 seconds. We'll say we're operating 100% duty cycle for 4 seconds. Just gonna change this to 7, 1, and then from there we'll slowly drop down. Actually, we'll quickly drop down to this 0. So let's say 50% duty cycle here, 0.5, and we'll do it at 7.5. Okay, that did not do it at 1, 0.5. Okay, no, where did my point go? Okay, let's try this again. 0.5, okay, and 7.5, okay. Why is it deleting my point? All right, we'll just leave it here and not really adjust it. And then we want it to drop right down to 0, maybe right about here. Okay. Why did it create these? Okay. Just delete that. Delete that. Delete that for me. Okay, it's just not wanting to cooperate right now. So I'm gonna set this to 0. Set this also to 0. Just so it's not the same time. I'm gonna do 8.9. 0. Just set to 0. Okay. Okay, that looks pretty good, except this is still here. 7. I'm not sure why I did that. Actually, I can I can delete rows right here. Okay, let's do that instead. So this is our signal. So we are speeding up pretty quick. That's why we call it the fast start. So now what we're going to do is we're going to save this. And we can close this tab. And here we have active scenario. So this is the scenario that's going to be running. It's defaulted to fast start because that is the only scenario we have right now. And the active signal is duty cycle, also because it's the only signal on that scenario. So we're going to press OK. And now you're going to see it's operating at the fast start with the fast start scenario with a duty cycle as the signal. So we can actually run this and we can take a look at how the rover reacts to this sort of input. Okay, not sure why it's timing out. Just stop the simulation. Okay, okay, I think we just need to edit this. I think there's just a problem with the solver. So let's maybe get rid of this line. Actually, no, that should be fine. That shouldn't cause a problem. So let's do interpolate data. I think that may have been the problem. And then after final data input set to 0. Okay, that should fix that. So let's just see what happens. There we go. Okay, so here we have the rover's velocity over time. So as you can see, we've got that really quick start at the beginning, and then it kind of levels out, and then we set another signal to increase speed, and then it gets up to max speed around, what is that, 3 seconds, and then it stays at max speed for 4 seconds, and then slowly drops down as our duty cycle drops down to, I think it was like 0.5. Yeah, 50% duty cycle at around 7.5 seconds, and then drops to 0 after that. So we, as you can see here, it just slowly slows down. If we ran the simulation, let's say for 20 seconds, we would see that this would eventually bring the rover down to 0 velocity at the end. Yeah, okay, so you can see it going to 0 at the end there. Now let's take a look at the electrical details here. So let's take this and expand. Actually, I'm going to make that full screen, make it much easier to see. And I'm just going to zoom in here. Okay, so as you can see here, oh shoot, I zoomed back out. Okay, let's do this. Okay, as you can see here, we are hitting pretty high currents at the beginning because we have a pretty big jump in our duty cycles. But as you can see here, we're hitting around 34 amps, and that's our max over the entire trip. So rather than going from 0 to 100% duty cycle right away, we can get there gradually and not have the crazy current draw peaks like we were having before. We still have pretty high current draw because like right around here, we're constantly pulling around 11.3 amps of current. And if you check power, that's about 136 watts for operating at 100% duty cycle, which is quite a bit of power for running for a long time, so you don't want to be running that long. But yeah, so that's the good thing about having the signal editor is you can change your signals however you like. So what you can do as well is you can create multiple scenarios. So if you wanted to, you can make scenario, blank scenario, and just call this slow start. And then we're going to add blank signal into slow start, and we're calling going to call this duty cycle. Oops. Duty cycle, and we're going to plot that. Okay, so let's say slow start, we want to be doing something like this maybe. So kind of slowly getting up there, kind of maxing out around here. Maybe go up a little bit higher, above 50%. Bring that, no, I don't want to do that. Okay. Bring that around to over here. And we're not going to quite go to 100%, and then we're going to start slowing down here. Okay, so let's say we want to do a gradual increase in speed like this. So we can save the file, close this, and we can actually navigate down to our slow start. We have our duty cycle, we don't have to change that, and we can press OK. So just want to make sure that this didn't change. Yeah, we just want to make sure we always have interpolate data on, just that way we don't get the errors that I had before, and always setting to 0 afterwards unless you want it something else. You can just hold the final value, which our final value is 0, so it'd be doing the same thing. But anyways, so save the file, and then we are going to run this again. Okay, so you can see we're definitely not hitting max speed. That's because we are not ever operating at 100% duty cycle, but we are gradually getting up to our top speed for this scenario, which is around what is that, 0.97 meters per second. And then once our signals start slowing down, then we start slowing down to 0 again. Then we can take another look here. This is our electrical output. Just going to scale this a little bit better. Okay, so here you can look at, let's say we want to see our current. Shoot, didn't switch over. Come on, current. Okay, and then, yeah, so it looks like this is about our highest point. So our highest current draw here is about 11.9 amps. So we did have a little bit of a steep slope there. That was a little by accident. I didn't mean to make it peak that much, but as you can see, the points where we have steeper slopes, we have a lot higher current draw. So when you're trying to plan out how you want to operate your rover, keep that in mind. Speeding up quicker means you're going to be taking a lot more current really quickly, and having big current jumps like that is never good for batteries or for power systems. So always make sure that when you're planning that out, try to run these simulations so you can see. And yeah, that was the whole purpose of making this simulation, was we wanted to see what would happen in terms of like how long our batteries would last over like a certain operating period with like certain input duty cycles. So that is basically our simulation finished. We have the full rover simulated. We have our custom signals being put into it. We have our outputs coming out. So we're seeing how the rover moves. We're seeing how much power it's consuming, how much current it's consuming. So in the next couple of videos, I'm actually going to show you how to build a GUI for this simulation. Not necessary, but it's really helpful when trying to visualize, or not visualize, but like see the changes between changing variables easily, and then just easy for people who maybe don't know how to use Simulink or MATLAB to run the simulations and make adjustments to the variables. So if you have people that, I don't know, like for me example, I have people on my team that maybe don't know how to use MATLAB and Simulink, I can give them this app that I made and they can run power simulations all they want without having to learn MATLAB or Simulink or whatever. So yeah, so in the next video, I will show you how to do that. Until then, you can pull this model from the GitHub so that you're ready for the next video. Next couple of videos will be pretty long, I would think. It's going to be very code heavy. Probably split it up into 2 videos, but I'll make sure all the code gets on the GitHub for you to pull if you want.